So let us discuss some examples of functions that are one-to-one and not one-to-one. So for this, let us first take fx to be equal to modulus of x. Is this function one-to-one? Let us try to answer this question. So let me write this function properly. So if f of x is equal to x for x greater than or equal to 0 and minus x for x less than 0. So it's actually a straight line on passing through the origin like this at a 45-degree angle, and the minus x is this line. Okay, so it's a V shape, 90 degrees V. So is this function one-to-one? First of all, let us not take the argument. First of all, is this a function? F of x is equal to mod x. Pass a vertical line. Take a vertical line and pass it through this. Is there if there is any point where 2 points, more than 1 points pass through this function, pass through that line, then it is not a function. So vertical line test is successful, therefore it's a function. Vertical line test says that it is a function. Succeeds, and we know it is a function. Okay. Now the question is the function one-to-one? Right? So you pass a horizontal line. So let me pass one horizontal line somewhere. Let us take this horizontal line. Now is the function one-to-one? For x1 not equal to x2, I got the same f of x. Okay. So how will I prove it is not one-to-one? Let us take a value which is say 2 and minus 2. These are the two values. F of 2 is equal to 2 and f of which is also equal to f of minus 2. Therefore, this is not going to be a one-to-one function. So it is not one-to-one function. So our conclusion is it is not one-to-one function. Then do we know functions that are one-to-one? So since we have taken f of x is equal to mod x, let us take a function f of x to be equal to x. Is this function one-to-one? It's a straight line passing through the origin. Is this function one-to-one? Let us take horizontal first. Let us check whether this is a function. Take a horizontal line, pass it through pass it horizontally, the line parallel to x-axis. So just drag x-axis up and down. Do you see any point touching more than 1 point? No. So it's a valid function. Then yeah, you have to pass a vertical line first. Okay, so start with f of x is equal to x, take a vertical line which is y-axis, slide it to the left, slide it to the right. Do you see anywhere it has more than 1 point? No. So it's a valid function. Then take a horizontal line, pass it from the top to bottom. See if you are getting any 2 points together on that line. No. Therefore, this function is actually one-to-one because x1 not equal to x2 implies f of x1 is not equal to f of x2, which is more or less expected, right? Because f of x is equal to x, therefore x1 not equal to x2 will give x1 not equal to x2, that is f of x1 not equal to f of x2. So what about, it is an exercise then, what about if you take a cubic function? So cubic function will pass like this. Sorry, it's not a correct diagram of a cubic function. So cubic function, let us change the color as well. Cubic function will have something like this. Symmetry will be retained and then this will go down. So if this function, now check whether this function is 1 to 1 or not. Again the exercise is very similar. Pass, let the x-axis go up and down. See if you are finding any 2 points together. So let us say this function is f of x is equal to x cube. And now you can easily make out that for x1 not equal to x2, f of x1 is not equal to f of x2. So again through horizontal line test I have detected that the function is 1 to 1. So let us write this particular test as a theorem. If any horizontal line intersects the graph of a function in at most one point, then the function is 1 to 1. Okay. So then what we will show here, if you want the proof of this, what we will show here is, if the function is not 1 to 1, then it will intersect, some horizontal line will intersect the graph of a function in more than one point. Right? So that is very easy to prove. So I will prove it graphically. So if the function is not 1 to 1, this is x-axis, this is y-axis. If the function is not 1 to 1, I can take this point and call this as x1, and I can take this point as call this as x2. This is how I can make function not 1 to 1, and then pass a curve passing through these 2 points and pass the horizontal line over here, which we have done several times now by now, and therefore f of x1 and f of x2 are same. They both are same, therefore the function is not 1 to 1. That essentially proves the point that if a horizontal line intersects the graph of a function in at most one point, then f is 1 to 1. Good. So we are good to go now. The next thing that will come is, can we identify the class of functions that are 1 to 1? So what class of functions can you immediately think are 1 to 1? For example, we have also seen some functions like, if x1 is less than or equal to x2, then f of x1 is less than or equal to f of x2. Or let us not put this strict equality, let us put this way, strictly increasing function. So what do I mean by, okay, let us can we the question is, can we identify the class of functions that are not 1 to 1? So I can obviously think of function of this form, x1 less than x2, f of x1 less than f of x2. Let me plot it and then my imagination will work fine. So this function is something like, if x1 is to the left of x2, then f of x1 should always be to the left of f of x2. Or if you are plotting it on the y-axis, then f of x1 should be below f of x2. This is the intuition, and you can draw a line joining these 2 points and let it go ahead. And this is true for every x1, for every x1, x2 belonging to A. This is true. Then I am done. But this function have a name, that is, they are called increasing functions. Okay. In a similar manner, if I multiply this function with minus sign, then I will get a function which is decreasing function, and that can be written as x1 less than x2 implies f of x1 greater than f of x2, and this is called decreasing function. Now you look at any increasing function, and apply your horizontal line test. What is a horizontal line test? Just now we have seen that if you take the horizontal line, roll it across the axis, across y-axis, and there should not be more than one point intersecting that line at any given point in time. Okay. So this increasing function and decreasing function will satisfy this phenomena, and therefore we can easily write this as through horizontal line tests that if f is an increasing function or a decreasing function, then f is 1 to 1. Let us see one decreasing function as well. What happens when the function is decreasing? As I go from left to right, let us say x1 is here, x2 is here. As I go from left to right, I get x1 here, and now according to the condition, f of x1 should be greater than f of x2, so it will be somewhere here, and I can have a line passing through, not line but the curve passing through this point in this manner. This is true for every x1 and x2 belonging to the domain, and therefore using our line test, horizontal line test, we can easily see that the function, whether it is increasing or decreasing, they are 1 to 1. This gives us a big class of functions that are 1 to 1. So 1 to 1 functions are not rare to find. 1 to 1 functions are abundant in nature and they are reversible as well. With this insight, we will go to our next topic, which is exponential functions.